Right, so this is a question on trigonometric identities, and what we have to prove is the following. We have to prove that tan pi by 4 plus theta plus tan pi by 4 minus theta is equal to 2 secant 2 theta, right? So this is what we have to prove. So we know what we have to go from here to here. That's great. And so questions like this, they're really about testing how comfortable you are with trigonometric identities. And that means whether you're comfortable with knowing what sine A plus B is in terms of sines of A and cosines of A and things like that, whether you know the expansion of this and whether you know the expansion of what cos A plus B is and things like that. So it's not so much about having a surefire way of going of solving this problem. It's just about expanding and going along and collapsing terms and then seeing whether you can just prove one side equal to the other side. So let's begin. So what I see over here is I see a term that looks like tan A plus B, and I see a term over here that looks like tan A minus B. So the first thing I need to know is what the expansion of tan A plus B is. Now tan of A plus B is simply equal to tan of A plus tan of B divided by 1 minus tan A tan B. Right. So this is what this expands to. So if I were to apply that same thing to tan pi by 4 plus theta, then that would mean that tan pi by 4 plus theta is equal to tan of pi by 4 plus tan theta divided by this whole thing divided by 1 minus tan pi by 4 times tan theta. Now pi by 4 is equal to 45 degrees, right? So tan pi by 4 is really equal to a very nice number. It's called 1. So tan pi by 4 is equal to 1. So let's plug in that value over here, and what we get is that tan pi by 4 plus theta is simply equal to 1 plus tan theta divided by 1 minus tan theta, right? Now that gives us the first term. So now we have to do tan pi by 4 minus theta. So this looks like tan of A minus B, right? So what is tan of A minus B equal to? So let me see if I can scroll down. Yeah, so tan of A minus B is equal to tan of A minus tan of B divided by 1 plus tan A tan B. That's what it's equal to, right? And so if I were to use this expansion and apply it to tan pi by 4 plus theta, then what I will get is tan pi by 4 minus theta, is equal to tan of pi by 4 minus tan of theta, this whole thing divided by 1 plus tan of pi by 4 tan theta. Again, tan pi by 4 is equal to 1, so this gives me 1 minus tan theta divided by 1 plus tan theta. So this is the second thing we've figured out, right? So the first thing we figured out was actually up here. This was the first thing. This was the expansion of tan pi by 4 plus theta, and this one's the expansion of tan pi by 4 minus theta. And the two terms needed to be added. So if so basically what we have now is that tan pi by 4 plus theta plus tan pi by 4 minus theta is simply equal to what was tan pi by 4 plus theta? Let's see. That was 1 plus tan theta divided by 1 minus tan theta. So this it's equal to 1 plus tan theta divided by 1 minus tan theta plus, and this was 1 minus tan theta divided by 1 plus tan theta, right? So this is this over here. So we got tan pi by 4 minus theta from here, and that one was, it's a little oh, this is far up above, so I won't draw an arrow, but so this one, this first term is really just tan pi by 4 plus theta, right? So let's just simplify this expression, and I'll just do this because right from this point on it's really just arithmetic. So let me just do that real quick. So this is I'll actually do this on a new screen because it gets very long and messy really quickly. So what do we have? So we had 1 minus tan theta divided by 1 plus tan theta plus 1 plus tan theta divided by 1 minus tan theta, right? So this is what we had. So this adds up to 1 plus tan theta into 1 minus tan theta, and what do we have? So this would be 1 minus tan theta whole square plus 1 plus tan theta whole square, right? So let's just expand. So this is something like a minus b whole square, and this is something like a plus b whole square. So we know the expansions of those. So that simply is sorry. So that simply would be, I'm just doing the numerator first. So the numerator would be, let's just do the numerator first. This would be 1 plus tan squared theta minus 2 tan theta. That's the first term. That's this over here. Plus 1 plus tan squared theta plus 2 tan theta, right? So that is this term over here, right? So the 2 tan theta and 2 tan theta, this is minus 2 tan theta and this is plus 2 tan theta, so that they cancel, and what we're basically left with is 2 plus 2 tan square theta, which I can rewrite as 2 times 1 plus tan square theta, right? So this is just the numerator. This is not the whole expression. So let me just keep this on the side, right? And let's now move to the denominator. So the numerator, I'm just going to write this again. So the numerator that we found was 2 times 1 plus tan square theta, right? The denominator was simply 1 plus tan theta multiplied by 1 minus tan theta, and this is simply equal to 1 minus tan square theta, right? So this is something like a plus b multiplied by a minus b. So that is equal to a square minus b square. So that's the reason we got 1 minus tan square theta. So now let's just put all of it together. So numerator by denominator, that was the whole value we had, is simply equal to 2 times 1 plus tan square theta divided by 1 minus tan square theta, right? Now at this point of time we just have a lot of tan over here. We have a lot of tan theta, and what we are looking for is 2 times secant 2 theta, right? So we have to go from here to here, and it really now depends on how many of the trigonometric identities you know in your head. How many formulas have you filled in your head? So so some of you might remember, hey, I know what cos 2 theta is in terms of tan theta, right? So I kind of remember that it's equal to 1 minus tan square theta divided by 1 plus tan square theta. Now you might remember this result, right? I usually don't remember things like this. I only remember the most fundamental expressions. Like I remember what cos a plus b is, and I remember some special case like what cos a plus a would be. So this I remember is equal to cos square a minus sine square a, but I usually don't remember the more exotic stuff like this, right? I know how to derive it, but I usually don't remember this more exotic stuff. But if you do remember something like this, then you would see immediately that basically what we have is the reciprocal of cos 2 theta. So by that I mean that numerator by denominator, you will basically say, hey, this looks like 2 times 1 divided by 1 minus tan square theta divided by 1 plus tan square theta, right? And I've basically rewritten this in this form, and this whole expression is nothing more than cos 2 theta, right? So this came from here, right? So if you remember this, and this is a big if you remember stuff like this, then you will basically say, hey, this comes down to 2 times 1 divided by cos 2 theta, which is basically 2 secant 2 theta, right? So you would stop here and you would say, oh, this is great, it's been solved, and nothing wrong with that. But I usually don't remember stuff like this. So for me, the numerator by denominator that we had, which was 2 times 1 plus tan square theta divided by 1 minus tan square theta, well, I will just say, okay, let me just try, you know, let me just try replacing tan theta with sine theta by cos theta, right? Let me just try doing that, and so for me it would be 2 times 1 plus sine square theta divided by cos square theta, yeah, this whole thing divided by 1 minus sine square theta divided by cos square theta. That's what I would do, and which boils down to 2 times, let's say, cos square theta plus sine square theta, this whole thing divided by cos square theta. This is the numerator, and the denominator would be cos square theta minus sine square theta divided by cos square theta. So this is what it'll expand to. That's what I'll do. Now, both the numerator and denominator have been divided by cos square theta, so I'll just cancel them out. And cos square theta plus sine square theta is always equal to 1, so that's great. And so what that expression I would land up with is 2 times 1 divided by cos square theta minus sine square theta. Now the most I know is the expansion of cos 2 theta. This I know is equal to cos square theta minus sine square theta. I usually can only remember simple stuff like this, right? And so when I see a cos square theta minus sine square theta, I know it's equal to cos 2 theta. And therefore I will say, oh, that's just 2 divided by cos 2 theta, which becomes equal to secant 2 theta. So depending on how many identities you remember, you can actually prove that tan pi by 4 plus theta plus tan pi by 4 minus theta is equal to 2 secant 2 theta, right? So if you remember a lot of identities in your head, then you'll be able to stop sooner and say, hey, this is equal to this because of these reasons. But if you're like me, who does not remember trigonometric identities easily, who just remembers like 3 or 4 basic ones, then you'll probably just put in a little more work to prove that the left hand side is equal to the right hand side. So that was the question, and that's how it's done.